sure is, and it'll spin. Yeah, so the random number generator is pretty much just a circuit right here that produces a random number. Isn't that crazy? And this can be used for many games like Monopoly, you know, because you use dice in there and you have to move a certain amount. They need a random number so that you're not cheating. You know, you could just pick to get 6 or 5 anytime you want. So that's the purpose of a random number generator. Another good game, as an example, would be Mario Kart, I guess. You know, like they assign random numbers to the items that they give you. So it needs to generate a random number to find an item to give you. So that's a good application of RNG. But, you know, right now we're just focusing on this circuit that only goes from 1 to 6 as, with the interface of a die. Woo. So here's the different areas of the RNG. First up, we have the analog section. So you press the button, then a signal goes through the analog section. It's sort of turned into a wave and is output by this through here. I'm not going to say it yet because I want to say it later, so we actually have something to talk about later. And it goes to the sequential logic section, which then outputs a good old binary number to be decoded by the combinational logic section onto the 7 LEDs. So the analog section, you got 3 resistors, 3 capacitors. One is a ceramic. These 2 are like radial. This is a 555 timer, and this on and off switch isn't really part of it. It just turns the entire circuit on and off. It's not really important to the analog section, or really any of the sections. It just turns the entire thing off. So yeah. Alright, so here's the purpose of it. Creates the clock signal for the sequential logic section, and it also creates a dice roll effect as it's like toggling the output of the sequential logic section. And also an interesting thing about it, the part that makes it random, is that so it produces this analog wave, and when you let go of the button, you'll notice that the wave starts getting like longer and longer, and I think that happens about here-ish. Like these are pretty together, and then right here-ish, you see it gets longer and longer. The longevity of the wave just increases, and then it's translated to digital by the 555 timer, as you can see, LM555CN, into a square wave or a digital signal as a clock input for the literally 3D flip-flops that are in the sequential logic section. I know, I'm pretty good at timing that. I didn't put too many pictures here, but you can still understand it. We have a picture of the basic circuit for it. And so basically that clock signal from the analog section keeps on toggling these 3D flip-flops in their asynchronous sort of thing. And basically, right, so we only want to go up to 6. We can't go up to 7. So basically what you're gonna want to do is, you see here it goes 1 1 1. These are 2 AND gates, so 1 1 1 outputs as a true, and since these are active low, we invert it to be 0, and the preset works and the clear work under that 0. So in all other cases it's high, but once it reaches 7, boom, it has to re-roll, and then it outputs a 1. And so basically, right, basically that's how we just keep it from going over, because there's no seventh side to a die unless you, is it called a septahedron? Or whatever. And so here's the combinational logic section. It has 2 ICs with transistors, AOI logic, and 7 LEDs and resistors, which are the interface of the sort of die depiction. And so it decodes the binary number output of the sequential logic section to sort of look like a die. And how we prevent 0 from happening, since there's no such thing as a 0th side of a die, is that alright, so imagine all of these are just, 0. Well, I mean, they are because they're set to ground, but, and so this 0 goes through here, 0 goes through here. We end up outputting a 2 actually, because, the 0 or the low is inverted here, and then it goes through the OR gate, meaning that a true is output, and it's connected to these two LEDs. So a high is output there, and the LEDs get lit, so it just puts out a 2. And that increases the likelihood of a 2, but, you know, we don't care. You'll be fine. You'll live. I guess that's something that could be improved on the circuit, but we're not going to worry about that. Spin. So here's my improvement to the design of the RNG. I just thought that it could stand to use a way to control how high the output can go. And so I'm going to show you it working here. So pretty much these are like the bits. So this one represents 1, this represents 2, and this represents 4. Let's say I want it to output like only up to 2. Then, all right, puts out a 1, then that's 2, then that's 0 because 0 is output as a 2, which sort of messes with the odds, but whatever, don't worry about it. Then it's 1 again. Or I want it to output only 1 and 0, which would probably be better since, you know, it's even. Then 1, 2, oh, 1, 2, yeah, pretty much that. It's the same. Wait, I didn't, okay. You know, 1, 2, 1, 2. So it's like even odds. That makes it so that, you know, you subtract 5 from the 6 possible outcomes. And let's say I only want it to go up to 4. That's the highest possible random number that can be output. Then, you know, 3 and 4, and then it resets back to 2. Or, you know, you can add them. So I want it to go up to 3. Then 1, 2, 3, and it resets. So that's basically how it works. These add up, and it's typically going to be connected to the 1 or the 2 or something. But, you know, maybe I don't want it to be connected to the 2. Then I just make it connect to the other 2. And so those add up to be true or false here. This is an AND gate. And then it just resets the entire thing back down to, you know, 0 or something if like all of these are low. And pretty much that's just how it works. You can add up pretty much just messing around with binary numbers. It's a good way to teach someone how to count in binary, I guess. Yeah, so it adds the bits so that you can deplete as much as you want from the circuit. Also, maybe if you want to like deplete all of them, I don't know if that works. I didn't try it yet. All right. Oh, that's silly. Yeah, it does that. That's cool if you want to do that. You know, I made this yesterday and I kind of forgot how it works, but it works, so don't worry about it. So yeah, that's my improvement to it. You know, you get to control so much. But, you know, while I was making it, since it took me like way too long to make it, because my first idea, right, was just to turn off the ability for the LEDs to even light up. And this kind of messed with the like dice interface. Just made it so like 1 is just this, 2 is both of these, 3 is both of these, 4 is, you know, and so on. And basically I was just turning off the ability for some of them to light up so that you could make it all cutesy and whatnot. And this sort of makes it possible to do 7, but it's kind of weird jump. So, you know, and it's the same principle. So like you just get double the control. It makes it so that you can control the likelihood of outputs. So yeah, that's pretty cute, I'm not gonna lie. Because like, all right, if I turn all of these 3 off, then it's gonna be more likely that a 0 is just output and none of these are lit than it is for, you know, like 1, 2, or 3. Or if I turn all of these off, then it's just going to be more likely that a 3 is output than a 0, 1, or 2. So you can just do that. That's a possible one, but it sacrifices the dice interface of the random number generator. So either or. I kind of like the first one more, but either or. Ooh, double. And that's it. Thank you for watching my presentation. And now we get to watch the cool animation. Look at those things spinning. You like that piano? I do too. I thought it was really cool. Such a dramatic ending. Alright, we'll just let the piano finish. Alright, well, thank you. Please give me a 100. Have a nice one.